Welcome to AIM 318, which episode, where we're going to talk about how to use AI/ML and especially Amazon Rekognition to streamline media content operations. My name is Anushree. I am a product manager on the Rekognition team, and joining me today is Sally Hubbard, Director of Media Management for PBS. So what can we expect in the next 30 minutes? There's a lot to cover. First, we're going to talk about some macro trends affecting the media space. We're going to do a brief introduction to Amazon Rekognition and highlight some of the core APIs that are relevant to media workflows. And then we're going to spend most of the time on a use case deep dive, where we'll discuss what are the use cases facing media customers. And that's where we'll have Sally share with us her use case from PBS and how they're leveraging Rekognition to help them deliver content to America's largest classroom. So let's get started. So when it comes to some of the macro trends affecting the media and entertainment space, first is there's more options than ever to view content. In the US, customers have over 300 video services to choose from. This year alone, we saw Disney+, HBO Max, Peacock, and more not only launch, but surpass subscriber goals in record time. And with these new platforms, there's more flexibility to view content. Viewers are picking when, where, how much, and on which device they're watching. I am definitely guilty of binging a few seasons of The Queen's Gambit over the last weekend. But all of this means that there's an accelerating demand for content. Instead of filling 24 hours of content for a general audience, content producers are now creating 24 hours of content curated to multiple different subscribers. And that is a real explosion in terms of how much content they need to generate, need to produce, need to prepare, and get ready to send to production. So at the end of the day, it comes down to how well can you engage your subscribers, how can you grow your subscriber base, and how can you keep them on your platform. All of that content from the 24 hours to 24 hours for each individual subscriber, and also needs to be at that same quality bar. So with the same resources, our customers in media are challenged to do more to enable these better experiences, which are now becoming the norm. So not only is the quality the same, but also because these platforms offer new functionality and interactivity, customers expect enhanced viewing experiences. It's no longer sit back, turn on some TV, watch some content. Customers are actively choosing what they watch, engaging with the platform, learning more about specific content titles, but also they've come to expect, let me skip the intro, let me move to the next episode. Let me see what else I can learn about the characters in the specific show, very similar to X-ray-like capabilities. And additional functionality around overlays when it comes to sports content that are real-time and in the moment. Finally, these new platforms that engage directly to consumers, that are DTC platforms, either OTT or VOD platforms, allow our media customers to innovate more when it comes to monetization. Whether it's tapping into the archive and surfacing content to kind of put more out there, to find those really unique or interesting director's cuts or BTS content, or launching contextual ads and native advertising that's more relevant to the consumers watching. This is the new bar and the new opportunity that's associated and that becomes available with these new platforms. So what does all this mean in terms of the workflows and how to deliver that content and what the expectations are? Viewers expect more. The bar is higher for more content, better content, richer content at the same quality or better. And what it means for our media customers is they need to innovate and accelerate that pace of innovation to differentiate themselves, right? Because it's a subscriber game. How can you keep your subscribers and maintain their profitabilities within the existing workflows? So why is that hard? Well, in preparing and managing the ever-increasing volume of content, the traditional processes just don't work as well. They're manual and tedious with rooms of people manually reviewing content. From a broadcast perspective, it could be a 24/7 video feed. And in quality and content operations, you have people watching every single segment. Because it's a human review, it's also subjective, which could lead to inconsistencies in the type of content that's generated. And there's what I almost call a blink and you miss it. If you turn away from your screen for 1 second, you could miss something that's critical to a compliance review and puts you at risk for unsafe content on air. Also, with large volumes of content, there's missed opportunities. If it's not automatically indexed or searchable, You may miss opportunities to surface something really interesting or unique or relevant to whatever story that you're trying to tell. And finally, with human workforces that don't leverage technology, it's expensive and it's not scalable, especially with the growing volume of content. So that's where Rekognition comes in. So Amazon Rekognition image and video is a deep learning-based image and video analysis capability. It sits at that top layer of the AI services stack within AWS's ML and AI services. And specifically, as you can see, there's a wide range of APIs and functionality. And specifically, we're going to deep dive into a few of them that are most relevant for media workflows, from our labels pre-trained out of the box API, which is pre-trained on thousands of different objects, scenes, and activities which may be relevant in your content, to text and image and video, which can help you identify text natively in your content, celebrity recognition, which is pre-trained out of the box on hundreds of thousands of celebrities, content moderation, where we don't tell you whether something's safe or unsafe, but we let you know the nature of the content that may be risky so you can make the right decisions about what's safe or not safe for your viewers. And finally, the last two features within the Rekognition suite that have been released in the last year: custom labels, which allows you to customize recognition, leveraging all of our investments in science to your use cases. Bring your own data and train a model without having to write a line of code or know anything about machine learning to find characters, products, identify types of scenes, identify lots of different things. And our video segment detection, which helps you identify shot boundaries, end credits, color bars, and black frames. So that's just a brief overview of the APIs. So let's dive into the specific use cases. So when we talk to our customers, there are basically three core use cases that come up again and again when it comes to media workflows and where machine learning and specifically computer vision can help. The first is content discovery, and here we mean appending really rich, relevant metadata to your content. With hours and hours of content, how do you know what's at second 23 or what's at minute 43 when it comes to a massive library? With this rich metadata that's searchable and saves time, you can then also create engaging viewer experiences and speed up content creation, whether highlight reels, promos, processing dailies to get to production, and more. The second use case really fits around operations, and this is around those quality control, monitoring, compliance workflows. And finally, the third use case is around monetization, which we talked about earlier. So ad operations, native and contextual advertising, and automating the reporting and analytics. So you can get it in hours as opposed to months with having someone manually review each logo placement to understand share of voice, etc. In this session, we're really going to focus on content discovery and content operations. So, discovery. So what is the problem we're talking about? The problem we're talking about is searching through hundreds and thousands of hours of content, looking for very specific things that may be relevant to your use case. Say you're putting together a Valentine's Day campaign and collecting content across many titles. To be able to find that, customers need to then watch every single second. But imagine if you could layer on machine learning on top of that. So you automatically are appending that really rich, relevant metadata that lets you search that content as opposed to having to watch every minute of that content and simply type in, find all video clips with this specific celebrity, or find all video clips that have this character, find all clips that have this specific spoken phrase, or find all clips that deal with romance because you're putting together a Valentine's Day promotion. That's what the power of machine learning and automating that rich metadata can do. But rather than hear it from me in terms of that automation and creation of rich metadata, I'm really excited to introduce Sally Hubbard from PBS, who's going to take us through the Sesame Street use case.
Okay, thank you, Anushree. My name is Sally Hubbard, and I'd like to talk about a pilot project we did at PBS with my colleagues Tina Lavanis-Probst and Maureen Harlow. So to give a little more background on PBS, it's a non-profit membership organization founded back in the 1960s that has member stations across the United States and territories. It has a mission of public service, and a big component of that is educational, to serve as America's largest and most trusted classroom. You or your children and their teachers may be familiar with PBS Learning Media or PBS Kids. So PBS carries a lot of great programming, and here are some of the best known and longest running shows. The digital library in its entirety is about 7 petabytes, or some 60,000 titles, which is like how we conventionally think about it, but that also translates to millions of moments. So thinking of our content in terms of moments or minutes speaks to a challenge we've identified, which is that there is a gap between what might be called traditional television metadata and our current informational needs. So we'll standardly have information at the series or episode level, things like season and episode number, a title, perhaps an episode summary, and that's all important information. We need it. But it's increasingly true that we need to have more granular metadata at the segment, clip, or even frame level to serve current business requirements, such as digital short form distribution, repurposing of the archive, etc. Essentially, we want to know what we have so we can know what we can do with it. To explore that conundrum further, we decided we wanted to see if we could connect time-stamped metadata describing PBS distributed content to an enterprise knowledge graph that we're in the process of building. Now, we're lucky enough to have a long-standing relationship with the wonderful folks at Sesame Workshop, who are the creators of Sesame Street, which is an iconic and beloved show aimed at preschoolers, and we were able to use their content in our pilot. Our knowledge graph, which we're using a tool called Pool Party, offered by the Semantic Web Company, models various things that are deemed important within the PBS knowledge domain, including shows, of course, the talent and the characters they depict, the PBS organizational structure, etc. The most mature part of the graph is an education taxonomy that represents preschool and K through 12 topics. So we wanted to see if we could make those two things meet. Specifically, we wanted to see if we could use machine learning to get granular metadata that we could map to the appropriate concept in the knowledge graph. So, for instance, teachers could find a clip to illustrate sharing or taking turns, etc. We wanted to get to something like what you see here. You see on the top right, there are concepts derived from our knowledge graph, so sharing, etc., etc. And then across the image, you also see this out-of-the-box insights that you can get from running ML, including facial, object, and mood recognition. So you put those things together, and you're getting much richer frame segment level information than we currently have. And then we could use that to find it easier to find appropriate content for use in, say, distance learning. Here's another representation of that segment, again, mapped to our knowledge graph, and you can see it allows us to contextualize within our knowledge domain. So the orange hierarchy allows us to tie the concept of sharing back to the preschool curriculum. The pink allows the series or franchise context with episodes, etc. And the green shows more in-depth character information and talent of that type of information. This is obviously a simplified representation. You can have all sorts of information here, genre, IP, etc., etc. And I should note that we are currently planning to use Amazon Neptune as our graph database to store and query the graph. But we have some questions about how to test out this concept. We didn't have internal resources available to us to write ML algorithms or even to work with the existing AWS ML services. So this is where GrayMeta and their tool Curio came in. It really made this project possible. The first question we wanted to answer is the one you see here. Does machine learning even work with Muppets? And I think we can definitively answer yes to that question. To give more detail to that, there are several key Muppet characters on Sesame Street that appear in almost all of the episodes. Some of them have been on the show since its inception and have evolved. They are also often nowadays appear in animated form or multiple forms. Abby Cadabby, the fairy you see here, is particularly visually complicated and additionally appears in multiple guises as both Muppet and animation. So ideally, it would be possible to build a model that would recognize all of those iterations, or enough to be useful and reliable. So we can find Abby Cadabby talking about table manners, or Elmo talking about sharing, and serve it up appropriately. So once you have the basic capability to create a model, the decision then becomes whether to do so becomes a business choice, and probably as much art and science as science. Is it worth uploading hundreds of images to use in training a model for a particular character? Probably yes, if that character is important and the model will get a lot of reuse. Probably not if the character is a one-off. So And here we have a quick demo of using Curio to train a model. So you see it's very simple. I think it's running, right? You open up the group you're training. This is speeded up a little bit. You open up the group you're training, you go to your previously uploaded still images, you draw a bounding box around the thing you want to be recognized, here Abby in an animated form. You tag it appropriately and you repeat and you repeat and you finesse it until you get the levels of accuracy you are happy with. And I think we'll see that in a second here. Just coming up. Yeah, there you go. So once you've done that, you can run a video and be able to see where that thing that you trained on appears. And you notice here, if you look on the top right, you'll see some hyperlinks in the speech to text, and that's because we were able to map those concepts and terms back to their URI within our knowledge graph. So we were able to have a direct link between the video and the knowledge graph. So to talk a little bit more about how this whole process worked, it was all API driven and cloud-based. Essentially, we uploaded our content to an S3 bucket. We were able to use Curio as our very user-friendly mechanism for training models and tagging content, with AWS services providing the backend. Or to put it another way, Curio processed our audiovisual material to create text-based inputs to send to Pool Party, which is a semantic and text-based tool. They were then mapped to concepts within the knowledge graph, and the URI was returned to Curio. So we were able to create insight groups, etc., by combining semantic and machine learning technology in something of a virtuous circle. So the results of this pilot was a production-ready mechanism, meaning that we didn't use any wiki-wacky workarounds to do this. It can be implemented as designed. So it's a mechanism that can provide high-quality, rich metadata to complement our existing data stores. We can see many uses for this, obviously around search and discovery and recommendations. It will allow us to know what we actually have in our library and be able to repurpose and perhaps repackage content. And in terms of cost and time efficiently, there are several places where some level of machine learning can potentially make regular media operational processing more efficient. So, next steps. Having found this mechanism that makes a process that would previously simply not have been possible at any sort of scale really feasible, the plan, if the stars align, is to integrate it into our regular media operations as we continue to move towards the cloud and apply it or scale it to our whole library. And recommendation is a very likely high priority use case. So that's it. Thank you for watching, and I'm now turning things back to Anushri.
Thank you, Sally. So diving in to give a little bit more context on what's going on under the hood, you just saw Sally walk through the GrayMeta Curio platform, and we wanted to tie it back to those APIs that we talked about at the beginning. So you saw custom labels in action with Sally and her team annotating and drawing bounding boxes around Abby Kadabi, so that way they could identify her in all content. But also under the hood, what's informing that really rich, robust, and thorough metadata is the full suite of Rekognition APIs. From labels to content moderation to celebrity recognition, all of those inputs help them create a very searchable, robust base of metadata to search that content, not just at the episode level, but also at the segment, frame, second level. So how would we apply that to an enhanced viewer experience? Using Sally's example from Sesame Street, we actually could apply that. Given the rich, robust metadata that she would have, we can take an episode like the screen grab you're seeing on the screen right now, which is Abby Kadabi and Elmo counting to 50, and layer over it that really rich second-by-second, frame-by-frame data to create these engaging experiences. So here, we've demoed what would be like an X-ray experience where you could learn more about the episode, you could link to more content about Elmo, about counting and further numbers, or more content from Abby Kadabi, perhaps hear her share more details on sharing. Finally, within that set of use cases that are unlocked from this really rich, searchable metadata, is the ability to create content faster. And to dive into that use case, we're going to look at the challenge PromoMe, another partner faced. And so what PromoMe was trying to solve was how long it takes to create trailers and how much manual work is required. So as an example, to create a 30-second trailer, an editor may take up to 5 days purely logging content, reviewing content, extracting the key segments, frames, video pieces that they would want to use, and only a fraction of the time actually editing down that video into a final trailer. With Nova, they aim to solve that, which is to provide an editing tool based using Rekognition under the hood that surfaces this really rich, relevant metadata content that would take editing content from 2 days to 2 hours and allow editors to spend more time being creative and less time manually searching for content and doing those other tasks. And this is especially important when working against a deadline or with the pure amount of volume that these editors have to process. So to see this in action, what you're watching now is a trailer, is a promo reel created using that the Nova tool, where metadata is extracted using the Rekognition APIs along with some of their proprietary ML models, and then able to be surfaced so designers, editors, and creatives can spend more time creating a really unique piece of content to engage a viewer, to get them to want to watch more. We've also included a QR code, so if you want to read more about this use case and see the reference architecture, potentially leverage it, and test out what a solution could look like, it's all right there. Okay, so we just covered discovery. Now let's hop into media operations, which is that second core use case that I mentioned earlier. Within media operations, it really covers a broad spectrum of use cases, but the two main areas that we see consistently from customers are streaming workflows, and this is mostly monitoring broadcast feeds to ensure compliance, quality, make sure the right content is airing at the right time according to schedule, make sure the right station logos are present, nothing's off. And the second one is file-based workflows. And so usually this is reviewing offline content to ensure quality, control, compliance, alignment to distribution and production guidelines, especially when those vary regionally. And what our customers tell us is that the low-level checks, there's a lot of solutions available in the marketplace that they can leverage. But for those high-level quality checks, they often have rooms like you're seeing on the screen that have operators watching feeds 24/7, watching every single frame, second, and minute of content, identifying those key areas, adding in markers, etc. So really, the goal in streamlining operations workflows is to go from something like we just talked about, a very manual, tedious review of every frame of video content, to something where machine learning can automatically review content and only flag the content that needs to be reviewed by a human reviewer. It's almost like a penalty box review process where the content reviewed is only that flagged by machine learning. So when we think about that overall solution and the specific use cases within these operational workflows, we see three different categories. The first is content preparation, so getting content ready for distribution. That includes inserting binge markers such as skip to next episode, removing color bars, detecting the commercial black frames and breaks, so that way content can easily be added, making sure all these markers are tagged. The second one is quality control, and that's really around ensuring the correctness of the program. Is the right content there? Is every minute of the right content there? And finally, the last one is compliance, checking content against global standards and practice guidelines, making sure that the right content is going out to the right audience, it's safe, and it meets all of the requirements. So what you can see is next to each of these workflows, the Rekognition APIs that are relevant are quite broad, and all of these help with these workflows. So diving in a little bit deeper into this under the hood, let's go into each of these individual APIs. So the first one, and if we look back at that first use case of content preparation, something like video segment detection really helps here. And with the video segment detection APIs offered by Rekognition, pre-trained out of the box, they help to detect black frames, where you can insert ads or where there's breaks between different segments or etc. End credits that really enable that skip to next episode. Shot detection and shot boundaries to make content easier to index and be able to then surface, extract clips, etc. And then color bars. When it comes to custom labels, this is where the nuances of your individual use case can be leveraged. So here, if you were doing a broadcast feed and you wanted to make sure you could monitor station logos to ensure the right logo is with the right market. Say you're broadcasting in both the US and France, for example, making sure the French logo is on the French content and the US logo is on the US content. You could actually train a custom model on all of the various stations as part of your distribution network and make sure that the right logos are appearing at the right time. The application of custom labels is quite broad, so in addition to detecting specific logos, you can also train classifiers to categorize content. And here you're seeing an example of a sports classifier to make sure the right sports content is playing at the right time in accordance with the schedule. So here there's a model trained on American football, soccer, etc., which can look at the content, identify what type of sport is this, and make sure that it maps back to what should be playing at that time. Finally, the last API we're going to go into detail on is content moderation. And here you can see, again, Amazon Rekognition does not flag content as safe or unsafe, but rather will report granular output that gives you a sense of the nature of the content so you can make the right calls as they relate to your policy. Not only do you get a top-level category as part of the API output, but then you get a second-level category to provide more specificity around what Rekognition identified. And all of these together can be used to create a solution that could get us closer to that streamlined operations. And so I'm playing a operations solution that we've built internally and is available. Again, if you use that QR code, you can link to the blog and reference architecture. But here, this is a broadcast monitoring solution with 4 specific checks, 1 for audio, and then 3 other checks based on using custom labels and video segment detection around the station logo, the right sport, and actually a model trained on team logos to make sure the right teams are playing as part of the right sports, mapping against a schedule. And here you can see that the machine learning models are automatically evaluating the content and extracting the key shots or segments that need to be reviewed further to ensure that they meet the requirements for quality control and compliance. So we just went through very quickly 2 of the core use cases around content discovery and content operations. And I wanted to spend a minute just highlighting the benefits of Rekognition, Amazon Rekognition for media. And hopefully these have become more clear as we've gone through the presentation. But first is increased efficiency. With even more work to do in less amount of time, faster deadlines, more content, automating this metadata, being able to process large content libraries automatically, reducing that manual content review and focusing on the higher value tasks increases the efficiency of teams and lets your team spend time doing what they do best, whether it's editing, fixing content that needs to be adjusted, etc. In line with a lot of the AWS APIs and services, Rekognition is highly scalable, highly available, and easy to use, right? Simple APIs, little to no coding required, etc. And finally, because it's a managed service and it sits at the AI services level, there's no machine learning expertise required. You get to leverage our investments in science and apply them to your applications. So what happens next, right? We just reviewed a lot of use cases. Well, there's lots of options depending on the level of ability and resources within your team. You can leverage partners like GrayMeta, like PromoMe, SDVI, Nomad to help with solutions that have user interfaces. We've also included a link to our developer guides if you want to play with the APIs and the Rekognition services directly. And finally, there's a link to videos and tutorials. So no matter what size your team, you can leverage some of the capabilities that exist within Rekognition today. And finally, we wanted to leave you with some more resources. So on this first page, there's a lot of different case studies. So these are customer examples and use cases on how they are using Rekognition to streamline and make more efficient their media processes, from Synchronized and TF1, who are using Rekognition to automate thumbnail creation, to Essence as Star Archive that really went through their large archive in advance of their Festival of Culture, to PromoMe, which you saw earlier today, and Video Fashion. Again, really adding rich data to that archive. On these next 2 tabs, we provide a lot of links to GitHub solutions, blog posts, and various starting points for these more complex workflows, from automating that broadcast video monitoring solution, which we shared earlier, to inserting ad breaks, custom brand detection using Amazon Rekognition custom labels, and more detail and demos on the video segment detection APIs, as well as custom labels and integrating human reviews. And with that, want to thank you for joining us today and hope everyone has a great rest of reInvent. Thanks.